All right, so let's take a look at number 5 here. We're doing linear systems, and we're talking about using elimination because look at both equations. They're both in standard form, or another way of saying that is the x and the y are on the same side and the number is on the right side. So it makes it really easy to line up the terms and do elimination. But you'll notice that, remember, the key thing with elimination is we have to have inverse terms. So one term has to have the same number and variable, but it has to have the opposite signs. So look at negative 2x. It's negative 2x both on top and on the bottom. It would be really nice if the negative 2x on the top stayed the same and the negative 2x on the bottom changed to a positive 2x. Wouldn't that be perfect if we could just change that bottom negative 2x to a positive 2x? Well, guess what? In math, you can. If we multiply things by negative 1, it changes the sign of all the terms. So, if I distribute this negative 1 to everything on the bottom, here's what's going to happen. So the top doesn't change, so it's negative 2x plus 9y equals 7. But the bottom equation changes, and this is what's going to happen. So negative 1 times negative 2 is positive 2x. Negative 1 times negative 7 is positive 7. And negative 1 times negative 9 is positive 9. So now I have my inverses perfect. Negative 2x and positive 2x. So we add these equations together. We get 0x. 9 plus 7 is 16y. And 7 plus 9 is 16. So x has been eliminated. And so you can change the problem so that you can eliminate. So you have to make sure they're inverses. So we made the x's inverses. So negative 2 and positive 2 are inverses. You can manipulate the problem so that the variables will cancel out. All right, continuing this particular problem, we would divide then by 16 to get y by itself. And 16 divided by 16 equals 1. So y equals 1. All right, so now I need to plug 1 in. And we can do it to the top or bottom equation. Let's do the top equation. Why not? Okay, so I have negative 2x plus 9 times 1 equals 7. So that's negative 2x plus 9, because 9 times 1 is 9, equals 7. All right, and then I have to combine 9 and 7. They're on different sides, so let's subtract 9. And I'm going to get negative 2x equals negative 2. So we divide by negative 2 on both sides, and x equals 1. So x equals 1, y equals 1. My final answer, of course, is an ordered pair. X first, then y. All right, so the key part here in number 5 was you have to manipulate the problem because you have to create inverses. So it was originally negative 2, negative 2. In fact, let me show you here. So it was originally negative 2, negative 2, but I multiply the bottom equation by negative 1, and it changes all the signs of the bottom equation so that I can have the exact opposites or the inverses right there, negative 2 and positive 2. So that's how you do that problem, and you just manipulate it so that you can get it eliminated.